Hey there, class. We are here to look at example number 3. This is from our dynamics notes. So basically, the example that we're looking at here, we have an elevator. We're told its mass, and there's a single cable that's attached here to the top of it. And this is how the this is how the elevator is lowered and lifted. We're also told that there is a certain acceleration that it will occur. That's going to be a maximum acceleration either up or downwards. So let's take a look at how we might go about this. So the first thing we're going to do here is we're going to draw a free body diagram. If there's an acceleration upwards, the tension from the cable is going to have to be larger than the force of gravity that is going down. Likewise, if our acceleration is in the downwards direction, the force of gravity actually has to be larger than the force of tension that's upwards. So I've showed that understanding here through my free body diagram. Next up, let's talk about our strategy. So basically, with any kind of dynamics problem, typically what we're going to do is we start off with our free body diagram, which we've done here, and then we're going to move into writing what I call a net force equation. And basically, the net force equation is you start it with Newton's second law. Here's Newton's second law: the sum of forces equals mass times acceleration. And if we take a look at our free body diagram, we'll notice we have a force upwards and we have a force downwards. So there's two forces that are involved here. So we're going to add the vector force of gravity and the vector force of tension to equal our mass times acceleration. Doing some algebra, I'm trying to isolate the force of tension, and I end up with the force of tension being equal to the mass times acceleration. And we made a substitution here, going from the force of gravity is mass times g. And then we can also pull out the m because it's common between here and here. And then it's a matter of substituting in numbers. So a real quick kind of conceptual understanding here is that if we have an upwards acceleration, that's going to be where our tension is at a maximum. A downwards acceleration will result in the minimum tension force. So as we go over here and substitute in, some things to note here is that the acceleration, remember, is a vector. So when it's upwards, we decided to call upwards positive, so that's going to be the positive acceleration here. And likewise, if we look over here, we'll notice that it's a negative on this side. So it's the same value, just a different direction in those cases. So after we've done all the math, we'll end up with the two values here of 4.68 times 10 to the fourth for the maximum tension, and looks like a positive 4.63 times 10 to the fourth newtons for its minimum tension.